Good morning, Michael. What are we going to do today?
Well, Matt, I think we're going to go back to looking at the derivative. Again, we think of the derivative as a way of approximating a function with a straight line.
So we started with the straight line mx plus b, so let's crank the power up by x by 1.
So looking at x squared, for instance.
Like a parabola.
Okay, so let's start by writing down our general formula for the derivative. The idea is we have a function, say f, you evaluate at a point x, and then you want to see how it behaves close to another point x naught. So x naught is a fixed number, like 3 or 7 or 17. And we say this should be approximately equal to a sloped line with slope m times x minus x naught. Right?
Yeah, let's do it. So f of x is x squared.
So we'll do x squared. So here we get x squared minus x naught squared. And we want it to look something like this, right?
Yeah.
Well, we can actually do an algebraic equality. We know we want an x minus x naught on one side. So I'm going to leave lots of space so we can do a little bit of algebra.
Okay, so now you got an x squared here, x to the power 2. You got x to the power 1, so let's pop an x there.
So I'll put an x here, right?
And now let's try this one, and we got a minus, so maybe we could put a plus there to make it easy, and put x naught.
Because we've got an x naught here with a minus sign. If we multiply it by an x naught, we get x naught squared with a minus sign, right?
And these cancel, x naught and minus x naught, so that's correct. Okay, so now what do we do?
Well, now we say we want an approximation. So the slope should not depend on this variable x. X naught is a constant, like 3 or 7, like we said. So we know x is close to x naught, so this thing is approximately x naught plus x naught, which is 2x naught. So there I've got my approximation. And this guy is my slope.
Hey, that's really cool, but it's a pretty simple function. Let's be a little more challenged and crank the power up one more.
I can do that easily. Let's do a cube. So put a cube here, a cube here. Now, of course, this is all messed up. So how do I fix this?
Well, you'll have to give yourself some space.
Let me get rid of this plus sign. So do the trick you did before where you tried to get the powers of x to be right.
Okay, so x cubed, we got an x here, so we got to put x squared there.
Okay, I'll put an x squared here. How about the x naught?
Minus x naught cubed, so plus x naught squared.
So I'll put a squared here. And there's a little plus sign.
Now we need...
Well, you got a problem, right?
You got a problem because you got x naught squared and x naught x squared. They don't cancel anymore. So we got to fix it.
Now, Matt, I'm pretty good at algebra. Let me show you a little trick that fixes it. Let me stick in an extra term, x times x naught.
And does that work?
That works because you see x naught times this x gives you an x squared times x naught. And that exactly cancels this minus x naught times that x squared.
Yeah.
And you'll find all the terms cancel that need to cancel, and you get this.
Oh, that's really cool. So now let's see what this is, and then we can go back and look at that again.
So if we approximate, remember we replace x with x naught. This gives me x naught squared plus x naught squared plus x naught squared. How many x naughts is that?
3.
3. So this guy, I'm just going to erase.
Put in a 3.
X naught squared.
Well, that's great. Now I got the challenge. X to the power n.
X to the power n. Okay, well, we've got a pattern going on here. Let's go x to the n minus x naught to the n. And this will be some big thing.
Give yourself lots of space. Lots
okay,
of space.
maybe giving even more space.
Yeah,
That's a
because
good
you
idea.
may need it.
Lots of space. Now we know on this side it's x minus x naught. That's the easy part, right? Because we know that's what we're looking for. It's this thing in the middle. So let's do the x to the n first. How do you get that?
Well, x to the n is x times x to the n minus 1.
Right.
So look, when we did 3, that was 1 less. Look at this. Here we have no x naughts. We just got a 1 here. The next term is x times x naught. So we put in an x naught and reduce the x by 1. So we got 1 x naught. So let's put
And you got exactly the pattern, Matt.
x to the n minus 2
And what should that be multiplied by?
x naught.
X naught. And then what's the next one going to be?
X to the n minus 3 times x naught squared.
Can I put a dot, dot, dot here?
Yeah, put in your dots.
And what's the last term going to be?
Well, it's got to be whatever we did before.
So we need they have to multiply together to give me x naught to the
So it has
n.
to be x naught to the n minus 1.
Great. And that's the pattern. The powers of x go down, and the powers of x naught go up.
And how many terms like this? Maybe you can finish this off now because we can collapse this thing.
Well, let's count. Here is x naught to the 1. So that's one term to the 2. So 1, 2, dot, dot, dot to n minus 1. So that's n minus 1 terms. Did I miss anything?
No, that's right, n minus 1.
Then there's this guy.
So there's n terms.
There's n. So this gives me n terms.
And every one, we're near x naught, so we put x equal to x naught here for
You get x naught to the n minus 1.
fantastic.
And don't forget our little linear part, x minus
Yeah.
x naught.
So there's our m,
This is our m.
which is traditionally done using the binomial theorem, which nobody remembers. And we've done it with simple pattern matching and this approximation. Congratulations.
Thanks so much, Matt. See you next time.